Hello everyone. In this video, I'm going to talk about how we use the standard enthalpies of formation to find things like the enthalpy of reaction. So this is part 9 in our calorimetry series, and we're building upon the previous video that defined what a standard enthalpy of formation is. Okay, so the enthalpy of formation for molecules is tabulated in Appendix B in your book. And so what you will find in this table are things where the molecule is listed, and then it will have a delta HF standard value. It turns out that just like in the KA/KB table, where those values corresponded to a very specific reaction, these values in the table also correspond to a specific reaction. And so the reaction that these values in the table correspond to are the formation of 1 mole of the substance that is listed from the elements in their standard state. And so for gaseous water, it's creating 1 mole of water from hydrogen gas and oxygen gas. Now, it's very likely that you are not going to be wanting to find the value of the formation of water, but instead you're going to have a reaction that has water in it. Say that we have a combustion reaction. So we have methane plus oxygen goes to form CO2 gas plus water gas. And now I have to balance this, and so I'm going to need 2 of these, and I'm going to need 2 of these. And so if I wanted to find what the enthalpy of reaction for this reaction is, I can use the enthalpy of formation for each of these species, because this enthalpy is a state function, and so it doesn't matter how I go about getting to this overall reaction. All I have to do is be able to find steps along the way for values that I have. And so that's how these enthalpies of formation come in use. So making this more specific, the delta H of reaction is going to be the sum of the enthalpies of formation of the products minus the enthalpy of formation of the reactants. And we can find the standard enthalpies of formation from Appendix B in your textbook. Okay, so let's see how this actually gets used. Before we do that, notice that the values in the table, so this is just a selection from your table where we have nitrous oxide and water gas and ammonia gas and oxygen gas. As you are doing this, the states of these materials are really important because you're going to have a different enthalpy of formation for a liquid than you are for a gas. But notice that the units in the table are in energy per mole. And so that means that we have to use the stoichiometry in our reactions to be able to make sure that we can get rid of the per mole. But also, we have to remember that these tabulated delta H formations are for creating 1 mole of the substance from elements in its standard state. So This means that if a reaction uses 4 moles of water, we have to multiply this enthalpy of formation from the table by 4 to get the proper amount of energy that's going to be required in the reaction that we are considering. Okay, so let's do an example now. So using the values for the delta H of formation, determined the enthalpy of reaction for the following reaction. And in this reaction, I have ammonia gas plus oxygen gas forming nitrous oxide and water. And I've been given a snippet of Appendix B from your textbook. And so the delta H of reaction is going to be equal to the sum of the moles of my products times my delta H standard of formation of my products minus the sum of my moles for my reactants times my delta H of formation for my reactants. Okay, well, great. That's a lot of math language. Let's work that out. And so I'm going to break this up into 2 colors because I want to separate my products and my reactants. So I'm going to start with my products. And so I have 4 moles of NO times my delta H of formation of NO is 90.3 kilojoules per mole, plus I have 6 moles of water times negative 241.8 kilojoules per mole for water. And I'm going to subtract my values from my reactants. And so in my reactants, I have 4 moles of ammonia with negative 45.9 kilojoules per mole, plus 5 moles from O2, and that is 0 kilojoules per mole. And so if I work this out, when I work this out and I type it into my calculator, standard, wow, this is not formation, this is reaction. And this is reaction. So whenever I work this out, I get a negative 906 kilojoules. Okay, so now let's just do another example. And so okay, so let's do another example. This is missing the arrow. And so this problem is asking us to use this information to find the enthalpy of formation standard of methanol liquid. And so we have that our delta H of reaction is going to be equal to our sum of our moles times our delta HF standard for our products minus the sum of our moles times our delta HF for our reactants. And so I'm going to start plugging in values. And so I have negative 638.5 kilojoules are going to be equal to, I'm going to give us some color for our products. Our products are 1 mole of CO2 times a negative 393.5 kilojoules per mole, plus 2 moles for our water times negative 241.8 kilojoules per mole. And I'm going to subtract the reactants, which are going to be 3/2 moles times 0 kilojoules per mole for oxygen, because oxygen is the standard state, plus 1 mole times our delta HF of methanol. Okay, so now I have to simplify and do algebra, and if I do this, I find that my delta HF for methanol is equal to 238.6 kilojoules. Okay, keep working on this, and I will see you in the next video.